First question that was asked off section 2.7, at least recently here, was problem number 19, where they give you this function here, and the directions were to find the horizontal asymptotes. So the first thing we needed to understand to do this problem was what it is that we're actually finding when they say to find those horizontal asymptotes. And what we talked about earlier in this section in the notes is that a horizontal asymptote is simply the limit as x approaches either positive or negative infinity of the function in question. So in a lot of cases, this is actually going to end up being two different problems right here. The first thing we need to do is figure out what the limit as x approaches positive infinity of f of x is. And then secondly, this is not always the same. We're going to have to figure out the limit as x approaches negative infinity of f of x. As we saw in our notes, it is possible for functions out there, especially more complicated functions, to have two different horizontal asymptotes. One that comes into play as x approaches positive infinity, and a different one sometimes when x approaches negative infinity. Sometimes they're the same, very often they're not, but we need to consider both of them. Now, this is a good example of what I considered to be the fuzzy math that we were talking about here in this section. Because we're talking about a limit as x approaches infinity or negative infinity, we get to take a lot of liberties with this function here. And now I'm kind of regretting where I put that right there, so I'm going to go ahead and get rid of that. What's going on in this function, everybody, is that because we're taking a limit as x approaches infinity, a couple of terms become negligible. Because we're talking about such huge values of x or such really, really small values of x, the 7 and the 4 are terms that we are able to ignore when it comes to a limit. So I'm going to say up above that this function then is approximately equal to just the square root of 36x squared up on the top and just the 9x on the bottom. The 7 and the 4 matter when x is really, really small, but they really don't matter much at all when x is getting to be a huge number. And not surprisingly, guys, 36x squared on the top is a perfect square. That should strike you as a funny coincidence that happens a lot in your radicand. So the square root of 36x squared becomes 6x. The bottom is just 9x, and the x's cancel. And that whole thing then is just 6 over 9, which of course is going to simplify to 2/3. So that's all that's going on there as x is approaching positive infinity. When we look at the second question, excuse me, the limit as x approaches negative infinity, it's very, very similar. The same rationale exists here, that the 7 and the 4 can be ignored, so I still feel pretty good about where we are right here. But we just need to remember that with x approaching negative infinity, our x values are all going to be negative numbers. Now that's not going to impact our numerator at all. Our negative x value is going to get squared first and turn positive, and then when we take the square root of that, that's still going to be a positive 6 up on top. But in the denominator, all of those x values are negative, which actually means that's going to be a negative 9x on bottom. So our answer is very, very similar here. But because we're going to negative infinity, this answer is going to be negative 2/3. So when the direction said find the horizontal asymptotes, this is one of them, and technically for a horizontal asymptote we should put y equals there. So that would be the horizontal asymptote that is relevant as we move off to the right in our graph as x approaches positive infinity. And here's the one now that would be relevant when we move to the left as x approaches negative infinity.